Welcome. This session is called Silverlight as a Gaming Platform. My name is Joel Neubeck. I'm Director of Technology for Terralever, a interactive marketing agency in Tempe, Arizona. And what we're going to talk about today is the use of Silverlight, specifically Silverlight 2, in the use of casual gaming. We're not talking about building the next Halo 3 in Silverlight, but the idea of using Silverlight as a casual gaming platform. So I just want to go through real quickly kind of the things that we hope to hit in this hour. And we're going to take about an hour and then hopefully have about 15 minutes in the end for any questions or further discussion of topics that we might need a little further explanation. We'll just go through the introductions, kind of what we do and how we got to here today. And then we'll start talking about architecturally how we design this game. We're going to talk in the context of the game specifically and all of the kind of pieces and components that went into this specific type of game. We'll touch a little bit about the .NET architecture, the procedural architecture, talk a little bit about the game logic that we used, a little bit about how our scrolling game works. It's a scrolling game that you'll see. And then touch on things like player movement, collision detection, our animation methodologies that we used, time-based, frame-based, things like that, and a little bit about the tools and techniques that we used. So why Silverlight? We've been doing interactive development for about 5 years, and what we found is that a lot of our clients have an interest in coming up with cool interactive elements that engage their users. We do a lot of work for Red Bull, and historically, we've done a lot of game development and interactive development using Flash. So Flash has been a platform that we've been pretty comfortable with, and we've produced, I think, 4 or 5 various casual games that get placed on different Red Bull properties. From that, we've kind of evolved now into having this new platform, Silverlight, as an opportunity to build additional casual games. So MiniClip, and how many here are familiar with MiniClip? Okay, excellent. MiniClip, I think, is probably the world's largest casual gaming site. I think they're about the 100th most trafficked site on the internet. And they came to us about 3 months back and asked us if we could build them a 1.0 game. And so we said, sure, let's take the things we know how to do in Flash and let's figure out how to use Silverlight to basically achieve that same thing. So here are some of the reasons why we thought Silverlight was a good choice, a good platform, a good tool to allow us to build this game. First, it's a compelling user experience. I mean, the performance is good, the visual nature of it is good. It's a very interactive experience for the users. The second big thing, and this really is very focused on the 2.0 game that we built, is that object-oriented managed code approach. We're a .NET, very heavy focused organization. So we have a very strong skill set in .NET. It's extremely interesting to us and very appealing to us to have the opportunity to use .NET developers along with interactive developers, interactive designers, to be able to have the best of both to work together to build a pretty cool game. And then a few of the other things that we've all heard a lot about in Silverlight, and that's the declarative XAML, things like role-specific tools, our designers using Blend, our designers using Design, our developers using Visual Studio, things like that. And then just the general rapid application development. When you can have .NET developers working alongside of your designers, interactive developers working along your designers, you're certainly going to have a more efficient, streamlined process. So let's talk about the games that we've done. This first game is a game that we did for MiniClip. It took us 3 weeks from concept to deployment on MiniClip's site. It's a pretty fun, cool game. Go check it out on their website. This game is entirely done using Silverlight 1.0. So the entire architecture is XAML and JavaScript. We were able to achieve a pretty cool, fun game. You move through the maze, you connect different tiles, swap tiles, do that in the most efficient manner possible. And as you progress through levels, they get a little more complicated. So that was a 1.0 game. We developed a second game, which we developed in 1.1 alpha refresh. So this was our first opportunity now to use managed code in a gaming platform. This was signatured on Silverlight.net for a while. Really fun game. You move around based on kind of a puzzle of different elements, and as you move through different levels, you get new game elements that you have to manipulate or interact with. Pretty fun game, written in 1.1. So that leads us to where we are today, which is the 2.0 game. So I'm going to call Chris Hill up. Chris Hill was our lead interactive designer. He's the guy that's responsible for all of the cool illustrations, animations, conceptually what this game was. And what he's going to do is just go through a demo of the game so you can get an idea gameplay-wise before we start talking about architecture.
Hi, everybody. I'm Chris Hill.
There you go.
Am I on?
There we go.
Guys, can you guys hear me? All right. Hi, my name is Chris Hill, interactive designer for Terra Lever, and just want to walk you through this this game here. We came about this game through, we started with our basic concept of what kind of game would we like to make, and looked at different possibilities, looked at our existing code base from Zero Gravity managed code games, and decided to work on a kind of top-down based platform puzzle game, similar in structure to the existing Zero Gravity game. So we decided to make a game about a beaver who is kind of a mad scientist beaver who's developed a little tunneling gun which allows him to make holes in walls wherever he likes. And an evil porcupine has come ahead and decided to take his kids away, and basic story premise here to push you forward through the game and work out what you need to do. So you have this nice little tunneling gun, and you can go ahead and shoot a hole in the wall, and then shoot a hole in another wall, and then walk in that, and come out over there. And we added a lot of elements. We loved the Portal game from Valve, and big fans of old top-down puzzle adventure games. So we borrowed elements from those and developed this note style here, which helps inform the player of different movements they can do, and also scoring, the mechanisms involved within the gameplay. We can go around here, and we kind of guide the player quite quickly through basic usage of the Portal system here. And there's a lot of notes explaining the basic concepts here. And when we were originally developing this game, we kind of worked from the concept that we wanted to see and moved on to the storyline, the premise, the silly off style of the characters, and the underground nature of it. We like the idea. So, and at the end of each level, you have your little darling child who gives you some praise and gives you a little quick rundown of your score.
F5 it and then go to a different level.
Yeah.
You can hit refresh right there.
Okay, cool.
We're going to just skip ahead so you don't have to see some of the entry levels. We're going to go to a level that has a few more game elements, a few more things that we'll talk about later that play into our collision detection and different game elements that are a little tricky to develop and design.
So once you've moved on beyond your early instruction levels, we slowly add new concepts as we go along. We don't want to overload the user with different ideas too early. So this is level 3, where we introduce the first use of deflectors, which we also use these red targets within the game to kind of explain to people this is where you should shoot in the earlier levels, and as the game gets tougher, we remove those and expect the player to kind of figure out where they need to go on their own. And there are different blocking areas, and the need to abstractly remember parts of the level that you've visited or seen, but not necessarily actually been to yet or worked out.
And I don't think we're hearing audio, but the entire game has audio, and I'm not sure if it's a computer thing or muted. Ooh, hit the game.
Well, there we go.
Good call. It's a little more fun with the little sound.
So the deflectors really add a kind of new aspect to the level design, where you have different deflectors that can change the angle, but also deflectors that can be distractions from the actual game process, or game progression, I should say. You don't necessarily know right away which one you're supposed to hit, giving it a little bit more difficulty. And we have lots of different belongings for the different kids within the game. And let's see if I can remember this level myself here. There we go, perfect. And work our way through to the end of the game. Good.
Cool. So, thanks
very much.
All right, so let's talk a little bit about what it took to do that. I think it's a pretty cool game. You know, I mean, if you start to get into it, it's actually quite addictive. You know, when you're doing testing in an organization and you ask people to start testing, you have to be a little careful, because all of a sudden an hour might turn into 2 hours, might turn into 3 hours, because it is fun. And as you progress, some of the levels get really complicated in the sense of kind of how you figure out how you move through there. It's a lot of fun. So let's talk a little bit about the design and the architecture. A few things that we would just want to talk about, and Chris kind of touched upon them. I mean, to build a game, you got to start with a concept. So we all sat in a room, we brainstormed, we threw around ideas, and ultimately came up with that game concept. And really it was driven from what were the cool game elements that we wanted. We identified things like we wanted a scrolling game. We wanted a game that had a level that was larger than you could see. We wanted things like movable objects. We wanted collisions that did things like picked up items that may have blocked your movement. We wanted the ability to show or signature doing things like a frame-by-frame animation that was moving across the screen in a more time-based animation. So all those elements went in there. And so someone like Chris, you know, sat down, kind of came up conceptually with what it was, did some hand illustrations, figured out what our props might look like, what those game elements might look like, and kind of how the overall script and story would work. And then from that, he actually went into illustrating, animating those elements, and then going into actually designing screens and designing all the individual pieces that you saw in there. And then from that, our rest of our development or design team got involved in being part of that process. So these are just kind of some of the first conceptual drawings that Chris worked from. And then from that, he used his Wacom tablet to do some of the illustrations. So here are the tools that we used. I don't think any of them are surprising. Visual Studio, obviously. Design. All of our level screens are done in design. We're entirely built in design. Adobe Illustrator was something that we used a little bit. You know, we know that it's important to allow our designers to use what tools they're comfortable with. It's how they're most efficient, most effective. So a lot of the designs were also done originally in Illustrator or even in Flash, and used Flash as a way to allow them to be comfortable with a tool that could then be exported into design, color corrected, modified, manipulated, and then brought into Blend to do all the animations that you saw. A couple of the other tools, one that you probably never heard of is Tile Studio. Tile Studio is just a super simple open source tool that lets us take a series of PNGs, define them as a map, and allow somebody to design a level. And that designing is just simply the organization of where tiles are going to go and how that flow of that level is going to work. So they can do that in this real simple tool, produces some XML that we then massage, and then we use that XML to build each of the levels in the game. So let's talk a little bit about the initialization architecture. One of the things that you might have saw when the game started was we had a pre-init that kind of shot in there, which was the introduction from Miniclip. This is significant because this is something that we couldn't really do as well in some of the other platforms. And one of the reasons was that we didn't want you to have to download all of the assets or all of the elements for the game to simply see that introduction screen. So the way that we did this is a very two-specific, Silverlight 2-specific technique, and that's the use of zap files, which I imagine most of you have heard now, but a second concept which is called partial assemblies, or the multiple assemblies that can be included in zap files. So what we did was, the initial person goes and hits a page, gets a really light amount of files in a zap that has some audio, things like that. And then asynchronously, we go and grab some additional zap files that have some additional assemblies, and they then start to load asynchronous to that intro screen. In addition, we have another zap file that's coming with all those things that aren't really necessary yet to get the game built. So using this idea of partial classes, or not partial classes, but this multiple assembly, we could actually really leverage the Silverlight 2 platform to make the experience better for the user. So this is a little bit what that load sequence is like. I think it's pretty interesting. So the user loads it, they load the page XAML, we then start downloading the intro zap, we get that really fast, it's tiny, we then use some reflection to pull those assemblies out of that, pull out those game elements, sounds, things like that, and then we move into the additional things. And it's kind of just 3 different zap files. So this is really how those things broke up. And as you can see, they're pretty small. So the user experience right away is fast. 140K, they see that. And if you notice, one of the things, which is a design decision Microsoft made, was that when a user installs Silverlight, they don't get all the pieces. Those are kind of an opt-in thing. So we chose to use LINQ for some of our XML parsing. And so we passed that as part of that payload to them when they get that intro. So that really, as you can see, really made that intro a little bit larger. Our intro for Miniclip is 50K. Our game, a little bit larger, 4 megs in size. I wish I hadn't installed it because you could see that it actually downloads pretty quickly. A zap file is just a pretty nice compressed zip file. All of our screens, tiles, and sounds are all embedded within the assembly within that zap file. So they get a pretty high level of compression. This is kind of syntactically how we did that. And there's lots of different ways to kind of skin that. But this is how we go and actually grab the Miniclip init zap file. We go and use this web client. The web client defines a callback. That callback gets fired. And then asynchronously, we can make additional calls like that to pull code. From that, then, when we get one of those zap files back, we can actually iterate through the manifest that exists inside of there and pull out every one of the assemblies that we might have in there. And that's a pretty cool Silverlight 2 feature, because it allows you to make decisions based on how far you're in the game or how far you're in the application as to when assemblies will get passed in. I think that's pretty cool. I would imagine everybody that's done programming is familiar with the model view controller. We made a decision architecturally to follow this model view controller pattern. There's a lot of industry opinion as to best ways to do it. We found that to be most effective, allowed us to build the game pretty rapidly, also allowed us to have a decent level of encapsulation and abstraction of elements that allowed them to do what they needed to do. So as screens or tiles changed visually, it didn't affect our gameplay. Or as the management of state changed, it didn't necessarily affect the way that the data was presented. This is a really high-level view of kind of some of the Silverlight pieces or some of the objects that went into how our flow and our game gets going. We preload is just kind of that concept of the user hitting the button, loading the screen. The first thing that we do is we load a view, a main page, which is a main XAML file. That XAML file then in turn instantiates our controller, passes itself through dependency injection to get a reference to it, and then it starts our controller's kind of that hub, that central piece that starts doing all of the things that we need for the gameplay to go. We preload all of our instruction screens, our level 1 screens, all of those individual things kind of get inserted into our primary canvas, and now in Silverlight 2, that primary user control, get inserted in there as elements. From that, we do some other things. We instantiate our game board. We instantiate our game board controller, which is just a kind of secondary controller that manages board events. And we'll talk a lot more about what that means. So let's talk about game logic. One of the things that was identified on that screen is a lot of the core of how this game works comes from our board controller. Our board controller is managed code. It's a C# class. And in there, we do specific elements that we're going to need for the game to play. We instantiate our collision detection. We attach all the handlers for the keyboard input. You saw some of the different keyboard input that we had. And then in addition, we attach some handlers to events that will be controlling things like the player movement or the act of a player being teleported from one place to another. And I just want to show a little bit of kind of some of how that code works. And syntactically, there's a million ways you can do all this kind of stuff. But one of the things might be we'll fire an event from some collision action that says the player needs to be teleported, and from that, we'll use our constructs and our models to be able to actually move that player. We'll scroll the player and do all those individual elements that would be necessary. How the player animates, things like that. So a lot of .NET stuff, but pretty cool ability to use managed code in a very object-oriented way to achieve a game in a pretty efficient amount of time. So let's talk about board composition. You saw in the game that we kind of had this concept of tiles. The entire game is a tile-based game. And each one of these elements that you see up on the screen represents an individual tile within the game. Well, one of the choices that we made architecturally was to come up with a concept of multiple layers or Z layers. And the idea there is kind of twofold. One, it'd be really cool to have the ability for a guy to walk over something and not even have to worry about collision detection. So we can have him walk over a skull that's perfectly adequate because he's not at that same layer as what that skull is at that time. In addition, we might want things that he just can't walk past, and so we can place him at that Z layer. And then in the future, we might be able to do things like walk up a set of stairs or something of that sort. So we have this concept of using multiple layers to allow our tiles to kind of nest on top of themselves. Each one of our tiles is a user control. So it's represented by a single XAML file that might contain all the different animations, all the different views of how that tile will be presented to the user. So an example like the jewel just has that single view. Something like the root might actually have a state when you first see it, it looks like the top tile. When you've acted on it or interacted with it, it goes to a second state where you've actually chomped through it and eaten through that tile. So this concept of layers allowed us to really efficiently design how the boards were done, because now we could take things like our illustrators could design a background image, and we could lay a rock on top of that and not have to go through all the different permutations of illustrations that you would need to achieve all of these different elements. So this kind of example is just us composing a rock of 4 different tiles with background images that might exist on different Z layers within the board. A second thing, is we also take some of these tiles, and instead of drawing a tile in every direction, what we actually do is we draw that tile, and then we just simply apply a transformation matrix to it when we position it in a certain spot, and just rotate it, maybe 90 degrees, 180, maybe flip it on its y-axis. So let's talk a little bit about board composition. The way that we achieve those multiple layers is that our tiles get inserted into a kind of a series of nested canvases. So what we do is we've got these canvases that exist in that root game shell, and then we insert those elements in there. And from that, we make decisions as to where the player is going to fall within that. In most cases, our player is kind of positioned in that middle layer. Let's talk a little bit about level boards. As we kind of alluded to, all of our levels, we have 10 levels in this game. We have the ability to add as many levels as we want. We use this tool called Tile Studio, and that tool allowed us to generate this XML. So we came up with kind of a schema of what we wanted our XML to define. It defines things like where should the player start within that level, where are all the tiles positioned, what's the relationship between tiles. Some of our tiles have relationships. You might select one tile that moves a switch of another tile. And so those relationships and positions are all defined within this XML. All of our tiles are 40 by 40, but we have the maximum of putting about 100 by 100 tiles. And that's just a limitation of Tile Studio. But we can put as many of those tiles as we found fit. Some of our boards are very long and rectangle. Some are a little bit higher in size. One thing that you may have noticed in that game is this concept of a screen. When you're looking at the game, you're seeing just a window of 10 by 14 tiles. You're not seeing everything that's around there. And we're going to talk a little bit about how that architecture works and how we're able to achieve that. So this is an example of what Tile Studio might have produced. So, one of our developers might have sat down and designed this level, and he went in, he put tiles where he wanted to, just dragged them in the positions, and then starts thinking about how those elements should interact, how those deflectors work, how the gameplay is gonna function. He lays that entire thing out, and then that produces us the XML file that we then will suck into the game at load time. So this is syntactically some of the code on how we actually parse that. It's like I said, everything that we have in this game gets embedded inside of an assembly, a DLL. And so what we're able to do, including these XML files, is we're able to use reflection and actually pull out these elements from that as kind of having them as one set of individual elements that we can modify that assembly. And one thing to point out is that we may send the original payload with 10 levels, so they get that assembly. But in the future, we could add additional levels that just came in as part of that zap, and that'd be perfectly fine. It wouldn't make sense every time we wanted to add a level to make them download an entire new assembly. So we have the capability of doing that. Within the logic of building the board, we instantiate some of our game logic, things like the player statistics you saw on the side. We define or instantiate our collision detection logic, and we'll talk a little bit about that in a second. Using that model view controller, all of our tiles have a corresponding model. That model is what's representing the logical state of that tile. So that model is doing things like keeping track and determining what the X and Y position is, or what rotation it has. It's keeping track of, am I in an up or a down state? It's also keeping track of things like, have I been picked up or not? And so we use these models then to, one, have a more object-oriented approach to it, but two, to minimize the amount of interaction we have to have with our views for the view having to keep track of what state it's in. Let's talk a little bit about scrolling. Scrolling was a pretty big thing in the game. The idea of scrolling we thought was probably the most essential or the most important part of this game. We thought that a lot of the games that we had seen on places like Miniclip didn't have that concept of scrolling the same way. A lot of them were front-facing, they're moving left to right, or it might be you see the whole screen and the player's moving around in different tiles. We really wanted to figure out how we could do that in Silverlight, and more importantly, how Silverlight would perform by us taking tiles and actually doing that. And we talked about using pixel-based collision detection or tile-based collision detection, and we opted to use this tiling approach and then to figure out how we could do scrolling with that. So our scrolling game board, one of the things that we really debated heavily on is, at what point do you choose to render all of your tiles? So we've got a little view of 10 by 14. Well, we may have 100 by 100 tiles. So at what point does it make sense for us to render all of those in the context of whatever canvases they're going to exist? And we ended up making the decision to render them immediately. And that posed an interesting challenge. May not have been the best decision, and maybe something that we'll look at in the future. But what it allowed us to do then is to get them all into the board. There's a slight delay when that level loads, but they're all there then. They're all already kind of inserted into our display stack, so we have access to them. We insert them all. We just make them invisible. One thing to note, and it has to do with Silverlight, and it has to do with the use of the user control and the concept of XAML. Every time that we insert a tile into another canvas, even if it's the same tile that we've used 4 or 5 times, the Silverlight plugin will parse that XAML. So right now in the plugin, there is no concept of a kind of resource area that we can store that XAML in and reuse that without it being requiring a parse of that XAML every single time. There's also not a concept of like a deep clone. And either one of those actually would make it a little more efficient. Because if we're going to take a tile and we're going to render it 5 times, it'd be great to parse that XAML one time and then just clone that object We'll clone it on stack in the heap multiple times, but we'll clone it so that we don't have to go through that overhead. And in a little bit, when we show you some of these tiles, some of the tiles with all the animations and the elements of them can be pretty large in size. And so that can be a potential area of performance that could affect things. One of the things that we do is we start a game tick or a timer. I think that's a standard gaming thing. But we begin a timer. The timer is just a storyboard that executes or fires an event every millisecond. And what we do is we control the visibility of what tiles are shown on that game tick. So every time that game tick fires, we're making determinations, and you'll kind of see when we talk about scrolling what tiles we visualize and at what point. So let's look at kind of how we broke up how we did this whole thing. Like I said, we put all these tiles. So imagine that there's 10 by 14 tiles in each one of those quadrants. We build them all up, and then we devisualize them. We collapse them. But what we do is we do make a decision that the player is going to be in a specific position. The scrolling nature of the board places him kind of in the center of the tiles that we've chosen to visualize. So that blue box is kind of what the user is seeing. The little bit lighter orangish box is the tiles that we've actually turned visible. So we're going to use a mask to show just that screen, but we're always going to have one tile in each direction to make sure there's no skip or line that occurs in there. The quadrants that you see in darker orange aren't actually visualized, but they're things that we're keeping track of because they're the most probable tiles that will need to be visualized next. So we're keeping track of all of those tiles around there in one collision detection and kind of our logical map of what tiles might come visible, and we're doing that on this kind of quadrant approach. So let's talk about player movement. You may or may not have noticed, but when he was moving around that player, the player is staying stationary or static in the center of that screen. So he's in the center of the screen, and the board or the elements behind him are moving, which is giving that perception of him walking. He is being interacted with, or the elements are being interacted with these pretty simple keyboard inputs. One of the things that we had realized when we built our 1.1 game is that getting this to work internationally was a bit of a challenge with just how keys mapped. And so we made a conscious decision to keep it pretty simple. And one of the, using left, right, and down. One thing to note is that some operating systems aren't a big fan of using control keys. So that may or may not prove to be a really great design decision. But the way our control key works is you click it, which gives it a state, and it kind of activates it. And then when you use your arrow keys, you can interact now in a different way with the tile. And if we would have showed you some additional levels, you might have seen us actually pull a deflector into a different position. And that activation of that pull movement is by hitting that control key. So now let's say we've moved, right? And so we've allowed that player to move to the left. As we move and we start to move further within that board, we now can remap what tiles might be necessary for us to be looking at. And so we kind of continue to use this quadrant approach to say, okay, well, now that he's moving, let's assume that he's going to be most likely moving within this realm of these tiles. There's some potential, there's a lot of places, as you might have saw with the way our projectile gets fired, where we have to visualize tiles very, very rapidly. And I was extremely impressed at how quickly, procedurally, we could go through all of those user controls and revisualize them when we're actually shooting, or it's actually more complicated when it deflects. When a projectile hits a deflection and now bounces in specific directions off that, we have to visualize very quickly. And as you saw, there was no points where tiles weren't being rendered. So I think Silverlight was performing quite sufficiently in that case. So let's talk about the projectile. I think the projectile is a pretty interesting game concept. It was certainly a pretty big challenge for us. For two reasons. One, it's the idea of, in a scrolling game, not knowing where it's going to end up until it collides, I think is pretty interesting. Two, was we wanted this idea of having deflectors. So coming up with a way that our projectile could actually interact with certain elements differently was an interesting challenge developmentally, or development-wise. So when you see that action of how that projectile works, it really ties in closely to how we deal with our collision detection. So what I want to do is just go back and just kind of refresh everybody really quickly on kind of this idea of the scrolling game board. And I just want to show really quick some of that idea of what we just talked about. So, we have this whole screen. One thing to note in here is that, we've chosen to just allow this outer area to not be part of the game. It's just a black background image. There isn't actual tiles that are interacting, but that player's in the center of that screen, and as I start moving then, right, I'm staying in that center, and I'm seeing the reflection of those elements. So now you can see kind of the challenge in how we had to scroll that. We've got to allow it to scroll with movement, but we also have to allow the camera to move with that player and how that works. A couple of things that we'll talk about with collision detection that are worth pointing out again is this idea that if I shoot against certain surfaces, I might not be able to do something. I may have defined that tile as being something that's unaccepting. A tile like this may have a deflection. A rock might allow us only to fire a projectile at a specific location within that object. So I just think it's really interesting to think, those elements that you have to account for and how that affects the gameplay. And as you can see, I think scrolling worked pretty well for us. We have one area where we've got a little issue with the Silverlight plugin that we think is just a kind of a fluke in how 2 is working right now, and that's every once in a while we see a tile not render correctly on an edge, and we think there's just an issue with how it renders when it's been transformed. But it'll certainly be something that will be corrected very, very rapidly. You only see it under really odd permutations of when the board is kind of scrolled over a tile that has been flipped on its X or Y axis. Does anybody have any questions so far and kind of the things that I've covered? We're going to leave some time at the end to talk about it, but just want to make sure I'm not moving too rapidly. So let's talk about collision detection. I would argue is the most important thing in this game. A collision occurs every time that player, every time we have a keyboard event and we say this player is going to move to the next tile or the next position, we consider that to be something that we're going to check or going to check to see if that individual has collided with an adjacent tile. Our collision, as I had said, only occurs at that same Z layer. So what we're able to do is we're able to kind of use our movement and our board controller to manage all that collision in a single place. We use methods within our collision detection class that just check to see, do we even have to worry about collision? Has blocking occurred? Do we have to block movement? And things like that. And I'll talk a little bit how we did that object-oriented-wise and more polymorphically in a sec. So let's talk about movement, right? And with collision detection. So I'm the little beaver, and I'm facing in an upward direction. When the player hits that key and he makes that movement, at that point is where we'll make that collision detection. And we'll make that by looking at a collision detection map that we've generated. So we've built up a big collection of all of our tiles that are visible within that realm of those quadrants. And we've decided, and we've placed references using generics to our models and the state in which those elements are. And what we can then do is we can act upon those tiles and have different behaviors. So for example, the skull happens to be something that I can stand on. So when I actually move into that, no collision actually occurs. It has no action. So the tile itself is actually going to determine how it chooses to be collided with. So when I move into that skull, nothing happens. If I were to move on the note, you saw that a new note view pops up. When I move off that note and my state changes, the note goes away. When I move on top of the jewel disappears. Kind of common things. A couple elements that are interesting that I'm not sure we were able to point to in the levels that we showed you, but we have an idea of a switch. If you were to walk on that very last tile, it would actually interact with a different tile. So you would step on it, another tile somewhere in a different part of the game would actually raise up. And it may raise up for 30 seconds or some predefined amount of time. How do we make that process more efficient? And the way that we did that is by using this generic collection. So, in managed code and in .NET, we've got generics, we've got collections. So what we decided to do was to have all of our tiles, no matter what they were, and player is considered a tile, all of them inherit from a singular set of base or abstract class. That allows us to define the kind of common functionality, the common pieces that are necessary for a tile. But more importantly, define the signatures of the methods that we'll use polymorphically then to determine how a collision occurs. So what that allows us to do now is to very quickly navigate through our map to see where a collision occurs. So I fire a projectile, I start moving through time, right? I hit and I do a check against that first tile that I considered a block on. At that point, I can call a method within that tile's model, which is the same method in all the tiles, that can determine what happens. Does it consume the projectile? Does it deflect the projectile? Does it actually allow the projectile to stick? And so I think it's an interesting approach to allow us to use generics to very rapidly. And we do it a lot because movement is, the game ticks a millisecond. We're very quickly looking at those type of collisions. And the next screen's just going to show you simply how you do that. It's really, really, really simple. Use a standard list dictionary that we all have been used in .NET before. We insert in there some arrays to allow us to achieve that multiple dimensions, the Z layer. And that's really all it is. So all those items are placed in as their base class as tiles. And so when we navigate through collision, we don't really have to care what it is. We just simply call those methods and allow those methods to make determinations as to what behavior will be exhibited. Media and animations. I would argue that the area that we spent probably the most amount of time on within this game is all of the animations and illustrations that we saw in there. Animation, I mean, the game would be nothing without the animations. And as you probably saw, there's a lot of different kind of flavors of different animations and animating techniques that we see inside the game. I think animations is probably what makes a game fun or not fun, right? Well, as everybody, I would imagine know that Silverlight has made a very conscious decision, and Silverlight WPF, to use a time-based animation technique, right? And what a time-based animation technique means is that they've defined this idea that when I have an element that exists and I want to animate that element from one position to another position, what I'm essentially doing is simply manipulating a property upon that element. So I'm saying that over this duration of time, I'm going to have the object move from this X position to this X position. And over that period of time, I might do things like have a key spline in there. I may tween the movement from one position to another. But in general, time is what's determining that, right? So in essence, you have these different states. You might have it opaque in the first frame. You might say in the next frame it's not opaque and it's in a different X position. And simply all you're doing is modifying a property within that element and then allowing Silverlight to determine the frame rate and the pieces that fall within there. And you notice, I mean, we leverage time-based animations in quite a few places. When that projectile is moving across the screen, it's moving in a time-based animation. We've defined a series of storyboards. We've defined them in such a way that we're saying what that X destination is going to be, and that X destination may be way off the screen, and then we're allowing ourselves to animate that object across. And in most of those cases, there's another animation occurring inside of that animation as it's moving. So how do you do then what you see in the game, which is frame by frame animation? Just in general, Silverlight is not a frame by frame animating tool. It's not designed that way, and that's a really interesting challenge. Interesting in the sense that this entire game is frame-by-frame animations. All those elements are frame-by-frame animations. So what we had to do is kind of talk about different ways in which we could do that and how we could use a tool like Blend to do the illustrations, but then also composite all those animations in a way that we could allow our designers to see how quickly they animated, see that frame animate, but done in such a way that it was pretty efficient and easy. And there's two approaches that we played with and used. The first we used in our 1.1 game, which was this concept of stacking frames. So, for anybody that's familiar with Flash, Flash is an entirely different paradigm. So how you animate in Flash is totally different because it's frame-by-frame animation. But in Silverlight, when I create a new frame in a storyboard, I'm actually not duplicating my user control or my canvas. So I'm not able to have a distinct element on one frame and a different distinct element on another frame, and the other one just disappear when I move to that frame within the storyboard. So one approach to doing that is to simply stack all those frames on top of each other. So the top frame might be that first view, and then behind that we'll stack each of those additional frames. Each of the frames will be set to be opacity of 0. And then what we'll do is we'll just write a very quick storyboard that does a discrete movement from frame by frame. So we'll decide what that rate is going to be of how fast we want to move through those frames, and then we'll actually animate that in a potentially forever loop, depending on the need of that. So that's one approach. I think from a design perspective, that's very difficult, because in a tool like Blend, you now have all these frames stacked, and you can't see the other frames, right? So now if I want to make an edit to that other frame, I have to go and hide the other ones. I've got to change its opacity, or maybe I have them all opaque and I just hide them by hiding their views. Well, the challenge with that then is when it comes into development, it's not in a state that we can use. So we came up with a different approach. Maybe not as efficient, but certainly a whole heck of a lot easier for our designers to use. And easier for us to maintain. And this is this idea of a canvas clip. So instead of stacking them, we chose to line them up in a left to right order, in an adjacent order. And what we did then is each one of those frames is built or are built to be exactly the same dimensions and size. We may have put a bounding box around it that we hide to allow our designers to position them easily, but each one is placed in an adjacent movement or an adjacent position. What we then do is we place all those individual frames inside of a parent canvas. And that parent canvas now is the entire size of all of the frames that we've decided that are part of this animation. We then will define what's referred to as a canvas clip on that parent frame. So now what we've said is this box, this bounding box, is going to be all that I'm going to visualize. Now what we'll do is we'll go in and we'll say, okay, now for every frame that we have, we'll create one individual discrete keyframe or double keyframe, and we'll move that bottom canvas one position to the left. And so we just simply take that bottom one. It's kind of old school how we did an image strip, and we just move it back and forth. And it's super easy for the designer to see it all, really easy to test. You can remove the canvas clip and still see it animate and just move back and forth. You can put that canvas clip in very easily and see it animate right within Blend. So you get that effect of a frame-by-frame animation right within Blend. And I'm going to show you that in 1 second, what that looks like for something like player movement. This is just a snippet of the XAML that goes into that front walking sequence. You saw a left to right, but this would be a front one. And this is just this idea of using these animations and these double keyframes to allow us to move through that strip. One important thing, obviously, is the idea of a double animation using keyframes. That's going to give us that time-based animation that we need. It's going to refer to what element are we going to manipulate, within that transformation matrix. So in this case, we're elementing the X position of that frame. And then one thing now, and by default, Blend will not create double keyframes that are discrete. It is a manual process that you have to do. You got to right-click on the keyframe, and it's a little counterintuitive. It's a hold in. If you do a hold in, it generates a discrete movement. So instead of that movement from frame to frame being tweened, it's just going to rapidly move to that frame. So each one of these frames then is just moving that canvas. And then our designers can decide, well, what's the speed in which they want that animation? And when Chris designed a lot of it, he used different rates depending on the effect he wanted, used a varying different number of keyframes depending on how complicated the animation is. So what I want to do is I want to just show you what that looks like within Blend. Yeah. Right. We're defining how fast the movement between those frames are. Now, I mean, Silverlight in general isn't a consistent frame rate, but in that context, that animation is moving at a consistent rate, and then as it moves across, they're determining that level of frame rate in between. But these are relatively small, so they're not affected. But there is the ability, or there is the potential that frame rate can change a little based on performance and resource allocation, I think. So. All right. So let's bring up Blend. One of the design decisions that we made with our XAML was to include, like in a tile like the player, instead of having a tile that represented different types of movement, we chose to include multiple user controls or canvases within this user control to show each one of the different types of movements. And what we did then is we allow each of those frames to exist in there, but we also allow then the designer to design all the different animation states that are going to be necessary. So we allowed that designer to put all those elements in one piece of XAML. The net effect of that is that that's a pretty big piece of XAML. Anybody want to take a guess at how big the player movement XAML might be in size? It's about 2.5 megs of XAML. So, okay, I mean, that's, here we got a pretty cool thing, right? We got a declarative XAML, right, that allows a whole lot of flexibility, right? I can see my XML, I can tweak that by hand. Downside, 2.5 megs for all of that data. So now it's 2.5 megs raw. When it gets compressed, because it is textual data, it does get compressed very well within the assembly. But it could be a lot better. And there are certainly areas within XAML that when you're doing things like this, where there's a lot within one little tiny element, that it would be great if there was more attribute definition within the XAML that allowed us to kind of minimize the verboseness of that XML and maximize the number of bytes that we use within there. But in general, obviously, the XAML is pretty cool because our designers, and not all designers are going to go into that XAML, but if they have to go in and tweak something, it's pretty easy to go in there and see that and visualize that. The other thing, obviously, is the use of something like design. So our designers, might do the color correction and do some of that within design, export that XAML. They can export that XAML and paste it directly in that well, and then they'll see it pop up in the object controller over on there on the side. All right, so let me just show you kind of this idea of these different animations. I have an animation loaded. This one here is his sidewalk movement. And if I were to take this and expand this a little bit, you'll see kind of all of the different containers that we talked about. In this case, we're using a canvas clip. So we have this, what we call a sidewalk frame container. That's that parent canvas. And inside of that, we have these individual canvases. On the timeline here, you'll see these series of discrete keyframes that have been defined. So if I play this animation, you'll see that rapid movement, and we have it set up to just be a forever loop. And it'll just keep going. And I think you get that pretty cool effect of him moving in a pretty real-like movement. Now, obviously, he's small in the game, so you don't see it all much. But absolutely essential game element. Without that, if he slid across the screen, it wouldn't have, I think, the same effect. So that technique, then, our designers can go in, they can do those illustrations, and I'm not going to lie to you, a lot of our designers actually did some of the animation testing in Flash with their Wacom tablets because they liked the way that a design brush works in that tool. They took that then, exported it into design, made all the tweaks to make it all look right, and then brought it into here to be able to put them in the right position, tweak them, and then in here, they can make any final tweaks and modifications. They can actually go in and modify the path data, maybe minimize some of it to make it a little more efficient. So there's lots of little interesting animations in here, right? So let's just look at a different one. Let's look at a back walk. So if we look at a back walk, we've got this canvas that's our back walk. We're also going to have a corresponding animation for what it's like for him to be walking backwards. We can load that, and then our animator can play that movement and can test it. So as you can see, the designers have just this awesome ability then to do it all in one place. And then we then can literally just take that XAML, have our corresponding model, and use it. So in our design workflow, this was very fluid. We may have made decisions that he had too much butt wiggle, and the designers could modify that or change that, and none of our additional gaming logic or any of those additional elements had to change. Thought that was pretty cool.
Did you choose to use vectors instead of bitmaps because of the compression of the XAML as opposed to the compression of images?
Wow, it's a little. We chose to use vectors. Let's say two reasons. One, in Alpha 1.1, there was a really bad problem in rendering PNGs. They did not render well. They did not render efficiently, and their movement wasn't really well. Didn't move move around very well. That was a pretty compelling reason. PNGs supposedly work a lot better in 2.0. We didn't have to use them. I think the other thing is that you have a lot of flexibility when you do it all in vectors, right? We can use those elements in lots of different places. When you have tiles, right, that match up, whenever you use something like a JPEG or even potentially a PNG, there is the potential of having some effect of how those tiles mirror up. And in our case, it was pretty important. The other thing is we could kind of layer our visual consistency of our colors really well. And I think the game looks a little bit better. I think the path data is bloated. And one of the reasons why we got to 2.5 megs isn't XAML alone. It is all the massive amount of path data. I think at last count in that, and I could be off, but was about 1,200 paths. So pretty large pieces of path data. They're pretty efficient, but a lot of path data. We could make this a lot more efficient, and there's ways we could do that. We could take a tool like Design, and we could go in there and really analyze that path information and reduce the number of pixels. We could make some of these things, actually, and I think Chris did a lot of that in his design, is maximize the number of points. But we could even do that more. And I think that option was pretty interesting to us. The PNG thing, I think, is one of the most compelling reasons. Yep. Oh, sorry. What?
I just want to add to that. With the fix of the PNG problem in 2.0, would you, at this point forward, continue using PNGs instead of paths since they're loaded and caused?
I think we'd have to do some performance testing because, I mean, when you put data into, when XAML aside, when you get it into the object, right, within the plugin, there is no need to load those images. I mean, we have that all mathematically. So I think there's a significant performance value in when we're rendering and visualizing tiles rapidly, that we're going to do that. I mean, object-wise, that object might have all that path data, might be a pretty deep tree, but I think it's going to render a lot more efficiently. We did consider using PNGs for the background tiles. Anything that was in background, and some of that has to do with some Silverlight issues, and Chris can talk to it in the end. We had some issues when tiles batched up, and they were two vectors that matched. There's some rendering that is a little odd in how they're butting up together, and so we actually had to oversize some of our tiles and create some kind of overlapping effect. But all in all, I do think the vectors probably, from a visualization perspective and an object tree perspective, are more efficient. Loading of PNGs is a resource. We could preload them all, I guess, and we might have had the value of reusing them. In backgrounds, I think there might have been some value. Was there another question? Right. Some of, I don't know, I don't even know is player probably the most complex path data? So he's probably the most complex, but our designers like working in vectors. And from a marketing perspective, there's some value in working in vectors too, right? It's really easy to carry those elements, compose them all together in design. Our level screens are all reusing a lot of those same vectors. I think that's pretty cool. The other thing that you can do with vectors, which is kind of cool, is we can composite them together and then cut and clip a lot of that data. So I want to show you just one more, a different piece of XAML, because I think it's interesting to just show you something else. I'm going to show you something like let's find it in here. Let me try to find a projectile. This was one of the game elements that you saw in here, this projectile. This is in an idle state. This is the shot, and I thought this was kind of cool. This animation was really fast, and if you expand it, we chose to use very few frames, and the reason that we chose to do that was because that sucker is moving all over the screen quite a bit. And so we chose to really, the effect is so tiny, didn't need a lot of frames, but the effect is really cool. And if you saw it in the game, that idea of an animation inside of a motion animation or a movement animation is pretty cool. And we use that all over the place. I think it was a pretty cool effect. Let me switch back. I just want to talk about one more thing real quick. Let's talk about sounds. Sounds, important part of the game. We didn't hear it in the beginning, but we have tons of sounds. The way in which our sounds work is we actually have all of our sounds embedded within our assembly. And then very similar to how we pulled out our resources, our XAML files, we actually extract all those sounds out. And we chose to kind of use a singleton factory pattern for how we did that. We basically wrote this object, and we grab all those resources out, just like we did the assemblies, and then we preload them all into this collection. And now we have this basically singleton that at any point in the game when we need to do a sound, we can simply reference it based on an enumerator and fire that sound. So there's two types of sounds that we have. We have our sounds that are just, rapid sounds for elements of the game, but then we had some background music that was looping. One interesting thing with the way we had to do sounds within Silverlight is that Silverlight doesn't do a great job yet at looping sounds. So taking one sound and saying it's going to loop doesn't work really good yet. Not everybody hears it, but there's a kind of skip in there. A way we got around that was we actually have two sounds, and we use an actual lead in and a lead out on it. So our background sound might have a 5-second lead in, and then we'll start that sound. When that sound gets to 5 seconds, 5 seconds might be bad, but let's say it's 5 seconds to the end, we start that same sound again in a different media element. And so now when that lead in catches up, that second sound is playing down the beginning by the time that first sound hits. And what we were able to do is achieve a pretty seamless loop within the game. A couple other things is by using this singleton approach, all of our muting of sounds is all controlled within one single object. So we have this single sound manager that at any point we can reference it. A user hits mute on the screen, all the sounds just don't get used then moving forward. So it worked pretty cool. Sounds is definitely an area that, and if you talk to some of the Silverlight team, sounds is an area that you're going to see a lot of improvements in the continuation of the beta period within Silverlight 2. There's a lot of improvements they can do in how the sounds perform. So that's all I got. I'm going to, now that Silverlight 2 is public, I'm going to be blogging a lot about this, and all the designers and the developers on our team are going to be blogging a lot about the techniques at a much higher level, about the elements and the ways in which they did things. I'm going to post all that on my blog. I please encourage you to go to terralever.com as well. We have a lot of information on there about the work that we've done. So, questions?
How much time did you build this application?
We built the entire thing from concept to delivery in 5 weeks. Team size, we had 2 designers. We had one designer doing levels or screens. We had one designer doing illustrations and animations. We had one .NET developer, strictly .NET coding guy, and then we had a interactive designer who is a Silverlight Flash Flex developer. And you guys want to come up? If you guys have specific questions in regards to kind of the development cycle, these guys were two of the key members, two of the leads on the team, and they can talk a lot more in depth about some of the individual elements. So really, team of 4, a project manager, of course, to kind of manage that producing of the game. And then we had our creative team from a concept perspective as well. So some of the creative design elements and decisions were made as well. Ultimately, Chris made a lot of those design decisions. Yes?
So the game was written with the alpha?
This game's written in 2, in what you will download from Mix today.
So you were able to get it early or something? Or?
We've been working as part of their TAP program. And so, that known, doing a game in 5 weeks, we didn't have 5 weeks ago what was released yesterday. So every day, almost every day, we were receiving a different change or modified bit. Whole interesting paradigm, what that does to a development team, let me tell you. They're incredibly responsive in that process, but it really built and grew over time. You know how every development project works. So a lot of what we did, we may do slightly different now moving forward, because some of the intrinsic controls that we now have, stacking panels and grids, we didn't have when we started. We have now. They're worth considering or contemplating their value moving forward. We did use some of the elements like the new intrinsic button controls, things like that within our levels that can be templated, which were pretty powerful. And all of them are using the new 2.0 user control construct.
Okay.
Anyone else? Yes?
Are you aware if the Silverlight engine, being a subset of Presentation Foundation, actually also uses hardware for rendering instead of software? In other words, you get better graphic performance with better graphic hardware on board.
And I did not believe that Silverlight actually pushes that to the driver, does it? I don't believe it does. I believe that one of the key advantages of WPF is that it actually pushes that onto the graphic card. And so those demos that you saw where the processor wasn't going up, because this is multi-platform, I don't believe they leverage hardware acceleration that same way. But I would refer to Microsoft for that. I can't speak directly to it. Yes?
I had a question about sound actually. Is there a way other than callbacks that you know of that you can fire off a sound according to a timeline? Like a storyboard, have the storyboard, a sound fire at a point in the animation?
The short answer is no, that I know of. That first mini clip intro that you saw had those 2 delayed sounds. The way that we did that was actually creating a storyboard with a lead-in time on the storyboard. So instead of leading in the audio, because we didn't want a long audio track, what we did was we took the storyboard and we offset it however many seconds we needed, and then we actually had to chain them together because they're 2 independent sounds. So we had the first one start at a certain second, it fires a completed event, which then instantiates that second sound that fires and plays and completes.
That sounds good.
Yeah. Yes?
Regarding performance, could you compare Adobe versus Microsoft?
How about, here, grab Hill's mic.
Yeah.
This is Casey Rawl. He was our lead lead interactive developer on the project.
I would say that most likely the performance of the game right now would be faster in Flash. The game does perform well. Most of the tiling code, the performance enhancements we did to the engine to try to minimize the number of tiles visible on the screen at any given time didn't do a whole lot in terms of upping the overall frame rate. The benefit of it was actually nominal. I think that the plugin is doing a pretty good job of clipping out, maybe even sometimes too good of a job, of clipping out visual elements that aren't actually on the screen. The technique that we used, that tiling system, was basically a Flash-oriented system where if something was still visible, even though it wasn't inside the viewable area of the plugin, it could still bog down the frame rate. So I think in that aspect, the performance is good. I think overall, though, if we had rendered the elements in a Swift and played it in the Flash plugin, it would have been slightly better. That's just an educated guess. I don't have performance metrics to go up and tell you specifically, but that's just my.
And Casey worked on all 3 of the games, so I think it's fair to say there is a difference in the performance, the evolution of 1.0 to 1.1 to 2.0. I think that's relatively significant.
Definitely. I mean, comparing the performance between 1.0 and 2.0, it's head and shoulders above. So it's not very far behind. And again, it's still in beta, so it's still being optimized, I believe. So we actually saw frame rates on the game improve over the 5-week development process as we got newer and newer bits. So I think it'll just get better from here.
With the media capabilities of Silverlight, what were your thoughts on, or were there any thoughts on possibly rendering out the animations in a third-party software, creating an API or WMV or anything, and loading those in, using a media element, rather than doing frame-by-frame animations?
We never actually, I don't think, considered that except in one aspect of the Zero Gravity game, our 1.1 alpha game. There was a portion of that game. Has anybody in here actually played Zero Gravity? Okay, cool. There's a level intro animation in that game where our main character, Lieutenant Bennett, is flying in a spaceship. And, sorry, did I cut out? Okay. He's flying in a spaceship, and it's full screen. And that animation was going to be really heavy in XAML, so we decided to actually do that in a WMV. But for the actual animating elements in the game, we never considered actually doing those in video. We felt that animating them in a vector format would be much more fluid.
You guys.
Yeah, there's an element that you can set on the Silverlight object when you instantiate it in HTML to tell it whether or not to display a frame rate counter. So you can also set the max frame rate, you can set the redraw regions, you can do all that type of stuff. So at least in that respect, you can see what elements are redrawing every single frame. You can see what your overall frame rate average is. I don't think that there's anything as sophisticated as a profiler right now. Not that I know of.
And we did, there were numerous places in the game that as we started to play, we actually tweaked things like animations and how quickly something animated and the rapidness of that to keep the frame rate consistent. And so that we were optimizing that frame rate based on some of the game elements as we were building it. Okay, cool. Yeah. The secret build of Blend for a Mac is that you run Windows, XP, or Vista on your Mac. Blend is a Windows-only tool. So I can't speak to our designers. Some of the Illustrator work may have come on Macs. All the development effort was Visual Studio centric. So certainly on PC.
I did do some. Is it working?
Just hold it up more.
Some of the work was done on a Mac, but for the most part, it could have been done on a PC too. There's really no difference between the tools we use on a PC and a Mac, but for Illustrator and for the Flash side of things.
Right. And we beta tested all the gameplay in the Mac. The Mac plugin was in sync with the Windows Silverlight plugin. So we were constantly testing back and forth to make sure that those two plugins were staying synchronized the whole time and that those elements were consistent between the two. And it plays the same way on both, which is very nice. Yes?
The one thing we didn't talk
What do you mean by player detection?
Well, if you load up the HTML, somewhere you have to detect whether the browser has the Silverlight plugin installed or not.
Oh, okay. Okay, yeah. In Silverlight 2, there's a huge improvement in how the install process goes. That is entirely abstracted from you needing to do anything. You have the ability to customize kind of a screen that shows, similar to like if you go to Microsoft right now, you're going to download that. They've got a custom screen with a little badge. They really worked on how they engineered that. And that whole process now doesn't require you to go to Microsoft to do that download. So like if I'm on a Mac and I download it, I simply click on my badge. The terms are within that context. I can see them right in the badge. And then I simply download the plugin to my box and install it. So we haven't yet optimized the background screen of it. But what we did in like the 1.1 or 1.0 game, Zombomatic, was we just basically took a screen snapshot. So they got a taste of what it's going to be like, convinced them to download the plugin, they click on it, and it's a pretty small payload. I think it was like, on a Mac, it's like maybe 3 megs in size. It's pretty small. Now, one thing to note is, I mean, we're choosing not to send a lot of the additional assemblies. Like, if this is a more rich interactive application, there's a lot more assemblies you'd send. You would just send them. One thing that we didn't talk about that I just want to touch on really, really quickly is isolated storage. You know how when you saw the game and users made it to level 5, okay? We're maintaining the fact that they're on level 5 by using this concept in Silverlight 2 of isolated storage, where we're actually storing on their user's PC the information to know what levels have they already passed. That allows that player to come back and start at the same level they stopped in, but all that data and metadata is stored without having to use cookies or anything like that. Yes?
Did you find, or did you test across multiple browsers, Safari, Internet Explorer, and did it work seamlessly across all of them?
Yeah, I mean, because it's really not dependent on the browser at that same level. We did all our Mac in Safari and in Firefox on a Mac, same on a PC. All of our developers use different ones. In some of the bits that were not release bits yet, there were some times where we may have moved forward with game code that the plugin wasn't in sync yet on that person's box, and that can have some more horrific effects. But that's a development problem. That's a life cycle of it evolving. So what you see today, I haven't seen anything, and I've tested it in 4 browsers, 2 different platforms. Yes?
Are there game engines that you recommend, like the Farsi or this extension, to help us get started with the
I'm not familiar with it in a context of Silverlight, but that's I'm a developer, and so that's not my core competency. Maybe one of these guys can talk a little bit to it.
I tried to talk them into using the Farseer engine when we started, but I couldn't do it. I don't know of any ones specifically. At one point, we wanted to release the code for Zero Gravity, but we realized somewhere along the line that because of what was going to happen with the 1.1 alpha, the 2.1 was or the 2.0 release was going to kind of make it a moot point. So what I'd like to see is to have us update that code base and then distribute it. From there, you'd at least have a base tile engine. But I think Farseer is cool. I'd like to try it. But other than Farseer, I don't know of anything else out there as of yet.
Great.
When's that at? Oh, nice to meet you.
Excellent.
Cool.
Well, that's it. That's all the time. Thank you guys for coming. We'll be